There is one idea that sounds like science fiction, yet refuses to disappear from serious scientific discussion. What if reality is not fundamental? What if space, time, matter, and energy are not the base layer of existence, but only a constructed environment? The simulation hypothesis suggests that the universe may be an artificial system created by an advanced intelligence, not necessarily for entertainment, not necessarily as a game, possibly as an experiment, a reconstruction of history, or something far beyond human imagination. If that were true, everything visible in the Milky Way, every distant quasar, every black hole, every atom inside the human body would be part of a computational structure. And the most unsettling part is this: it might be testable. Reality has a resolution limit. Modern physics already suggests something strange about reality. At extremely small scales, space and time do not appear infinitely smooth. Quantum mechanics and general relativity both point toward a fundamental scale known as the Planck length. Below this scale, current theories break down. This is approximately 1.6 times 10 to the minus 35 meters. That is not just small, it is a possible pixel size of reality. If the universe were a simulation, it would likely have a maximum resolution. Just like a digital image cannot display detail smaller than a pixel, reality might not support distances smaller than a fundamental unit. Some physicists have speculated that space-time itself could be discrete rather than continuous. If true, the universe would already behave like a computational grid. The cosmic speed limit. Every simulation has constraints. In our universe, there is a maximum speed, the speed of light. Nothing can move faster through space. This limit is built into the structure of space-time itself. In a computational universe, a maximum speed could represent a processing limitation. Information cannot update faster than a certain rate. The speed of light may not simply be a physical constant. It might be the maximum bandwidth of reality. This does not prove anything, but it is an intriguing parallel. The energy cost of rendering a universe. If the universe is simulated, rendering every detail at full precision at all times would require unimaginable computational power. But simulations do not always render everything. In video games, distant regions are simplified or not rendered until observed. Could something similar happen in cosmology? Quantum mechanics introduces the idea that particles do not have definite properties until measured. Before observation, they exist in probability states. This has led some thinkers to speculate that reality may only fully resolve when interaction occurs. The famous double slit experiment demonstrates that particles behave differently when observed. It does not prove simulation, but it raises uncomfortable questions about the role of observation in shaping reality. Searching for glitches in the sky. If the universe is a simulation, there might be detectable imperfections. These would not look like flickering pixels in the sky. They would appear as violations of expected physical laws at extreme scales. Physicists search for tiny asymmetries in fundamental constants. They test whether physical laws are identical in all directions. They look for irregularities in the structure of space-time at high energies. One potential clue could be anisotropy in cosmic radiation patterns, such as irregularities in the cosmic microwave background. So far, the universe appears remarkably consistent, almost too consistent. The laws of physics hold across billions of light years. If this is a simulation, it is extraordinarily well optimized. The limits of computation. There is another angle to consider. The observable universe contains an enormous amount of information. The number of particles, quantum states, and interactions seems far beyond what any civilization could simulate in detail. However, some theoretical work suggests that the total information content of the observable universe is finite and proportional to its surface area rather than its volume. This idea is connected to the holographic principle. If reality encodes information on a lower dimensional boundary, it begins to resemble data compression, and that sounds very computational. The holographic principle emerged from studies of black hole thermodynamics, particularly work inspired by physicists like Stephen Hawking. It suggests that three-dimensional space may be a projection of deeper information. Projection is exactly what a simulation does. Could we ever prove it? Here lies the core difficulty. If the simulation is detailed enough, internal observers might never access the layer beneath it. Characters inside a video game cannot directly examine the computer hardware running their world. They can only study the rules within their environment. Even if scientists discovered that space-time is discrete, or that reality behaves like a computational lattice, that would not automatically prove simulation. It could simply be the way base reality functions. Any observation we make is filtered through the system itself. We are testing the rules of the game from inside the game. The probability argument. Some philosophers and scientists argue from probability rather than physics. If advanced civilizations tend to create many simulated universes, then simulated realities might vastly outnumber base realities. In that scenario, statistically, any randomly selected conscious observer is more likely to exist inside a simulation than in the original universe. This argument does not rely on detecting glitches. It relies on assumptions about technological progression and computational capability. If intelligent life survives long enough and avoids extinction, it may eventually simulate entire universes, and those simulated beings may eventually simulate their own universes. Reality could be nested, layer within layer. The cosmic silence. One of the strangest aspects of the universe is the Fermi paradox. Given the vast number of stars and planets, intelligent life should be common. Yet, the sky is silent. One speculative idea suggests that advanced civilizations may avoid revealing themselves because they understand the nature of reality better than we do. Perhaps the universe is monitored. Perhaps extreme technological signatures trigger something. This remains pure speculation, but it demonstrates how the simulation hypothesis intersects with astrophysics, cosmology, and even the search for extraterrestrial intelligence. If it is true, if the universe is a simulation, then black holes, galaxies, supernovae, and even the expansion of space are part of a design system. The Big Bang would not be the ultimate beginning, but the initialization of a program. Death would not necessarily be annihilation, but termination of a process. Physical constants would be parameters. The question then shifts. Not what is the universe made of, but who or what is running it, and why. Until there is empirical evidence, the simulation hypothesis remains an extraordinary possibility without confirmation. Yet it forces a profound realization. The deeper physics goes, the more reality resembles information, and information can be computed. Whether the universe is truly a simulation or not, the search for that answer pushes science to its absolute limits.